So let's go for next problem. And this problem, it is given that there is ultraviolet light of wavelength. The wavelength is given, and this is given 350 nanometer. And this light has also, it is also giving the power is given as 1 watt per meter square. Power is nothing but the energy of energy per unit time per unit area is the power. So the light pulse or some ultraviolet light have this much of energy and this much of power. What we have to calculate, we have to, and this light will come to some photoelectric, some metal plate which can produce photoelectric effect with work function. So work function is given 2.2 electron volt. So the light pulse will come here. This will take this, the electron will absorb the energy and it will come, it will just eject from here. So first we have to calculate maximum kinetic energy. First we have to calculate maximum kinetic energy, and second we have to just second is there is more beautiful information is given. What is that? That is given that only 0.5% 0.5% of electron, sorry, 0.5% of photon will produce photoelectron. So find the value, find the number of photoelectron and number per second. This will be number per second of photoelectron from area of 1 centimeter square. So if we can take the area, suppose this is the area of 1 centimeter square. So these photons are coming here and it will just eject the electron. So we have to calculate number of electrons. So second question is very interesting. The first is very trivial. So for first question, but we have to use the first, the information of first will use into the second one. It is given that wavelength is 350 nanometer. So first we have to calculate the maximum kinetic energy. So let's first calculate the total energy of photon, and this energy will absorb by these electrons. So the energy of photon will be hc upon lambda, and that will be 1.24 into 10 to the power minus 6 electron volt meter by 350 into 10 to the power minus 9 meter, and which will equal to 3.5 electron volt, and which is equal to 5.68 joule. Sorry, 5.68 into, so this will equal to 5.68 into 10 to the power 19 joule. So this is the information we have. So maximum kinetic energy is given by, so kinetic energy maximum is given by hc upon lambda, that will be this value, minus work function. So this value in the electron volt, work function is given in electron volt. So this will be 3.5 electron volt minus 2.2 electron volt. We can get this answer. So this will be, we have 1.3 electron volt. So this is, the first question is very trivial, very straightforward. But second question is very interesting. So in the second question, this is the power. And this is the energy of one photon. And we have to keep in mind that a single electron will produce a single photoelectron. This is the very interesting thing. So first we have to calculate how many number of photons will come onto this particular photographic plate, and out of this number only point only 0.5% will produce photoelectrons. So if we will going to calculate number of photoelectrons, then only we can then only we first we will calculate number of photons, then only we can calculate how many number of photoelectrons come out. So let's try to calculate it. So we have power, so we will use all this information of power. So first, what will be energy? The energy of the photon, a single photon, is 5.68 into 10 to the power minus 19 joule. So what will be number of photon? The number of photon will be power by energy of single photon into area in which photon is coming, and that particular area from where photoelectron is coming out. So this is, so what is power? So this is number per unit time, so per second actually. So what is power? So power is given 1 watt meter square. Area is given into centimeter, so we have to change into meter, 10 to the power minus 4 meter square. And yes, single photon, so single photon will have energy 5.68, that will be 5.68 into 10 to the power 19 joule. If we are able to calculate all this number, then this number will be 1.76 into 10 to the power 14. So this is number of photon per second. So power is energy per unit time per unit area. So we have find number of photon per second because we have divided with a single photon. So it is just coming like a beam, but single photon will tell how many photons are there. So if 100% photons will produce the photoelectron, then we have this number of photoelectrons. But in this problem, it is given 0.5% of photon will produce the photoelectron. So number of photon which will produce photoelectron is equal to, so 0.5 is all about 0.0005 into this particular value. So that is 1.76 into 10 to the power 14 per second in term of number per second. And if we are going to calculate all this value will be come to appear that 8.8 into 10 to the power 11 photon per second, and which is also equal to number of photoelectron. So it is very important that what is the good thing into this problem, what we have to learn in this particular problem. First we have to learn how this power is related to number. So if we can find the energy of one photon, then we can easily find how many numbers are coming, how many number of photons are coming from the whole beam. And this is the power of beam. Which wavelength is this one? One particular photon has wavelength this one. So we have calculated this particular EP. You can say this is energy of photon. and power into area will give you that power is nothing but the energy per unit time per unit area. So power into area will be energy per unit time, and divided by energy is number per unit time, and that will be number of photon per second. So this is nothing but the number of photon per second. But the beautiful part of this particular calculation is number of photon. In the ideal case, if 100% is photon is going to produce this photoelectron, the number of photon and number of photoelectron will same, because every photon will produce one photoelectron. This is the ideal case, but it is it, the data is realistic. The all particular photon are not able to produce photoelectron, because it is matter of chance that which electron is just accepting, which electron is absorbing the photon or which are not. So it may be the sea of electron, but it is not necessary that every electron will produce photoelectron. So in this particular problem, it is given only 0.5% is producing the photoelectron. So if we are able to calculate the effective number of photons, and that is exactly that effective number of photon will produce the photoelectron, and yes, we have to find in which area we have to produce it. So obviously that area will be 1 into 10 to the power minus 4 meter square. You have metal, big metal plate, so in some portion of area you can just find how many number of photoelectron can we come out if you know the energy and the power of this particular thing. So from this particular problem, I can end this topic. So you have seen that this topic is very straightforward, very simple. What you have to do, you have to just focus on the concept and the basic calculation. The basic calculation is very important when you are using electron volt, when you are using a wavelength, when you are using frequency, when you are using joule, and what are the basic concept and all kind of thing. So you can revise it again and again and just try to solve all other different types of problem from previous year and any another sources. So take care. Thank you.